Okay, hello everyone. So I'm Alix Kont and I'm a EHS senior professional for Schneider Electric, and I'm together with Thomas.
Yeah, hi, I'm Thomas Trebieng from Trebo, co-founder and COO.
And today we're going to talk about the prototype that we have made on the first circular socket outlet based on end-of-life materials. And to give you a little bit of context behind who is Schneider Electric, so we are bridging progress and sustainability for all. We are a worldwide company. You might know us as we were elected for the second time as the world most sustainable company of the world in 2024. And given this small introduction, you would understand why we had focused on circularity for the sockets. So when we talk about circularity, we have chosen to make the test in Denmark. Why in Denmark? Because in Denmark, we are producing high-quality sockets and switches, and we are covering a large part of the market shares. So meaning that if we want to study the end-of-life sockets, then it would most probably be ours that facilitates the circularity and the treatment of the end of life. So you can see here a picture of the LK Fuga socket. It's really well known in Denmark for those who are Danish or know Denmark. This socket is produced around 2 million units a year. It has a really long life cycle, around 30 to 50 years. So we thought that it would be very interesting to understand where does it go when it's ends of life, and how can we get the materials to re-inject it for remanufacturing in our Schneider plant. So we have made a 2-year project together with the Danish Technological Institute to understand the entire flow and build the first prototype of it. So let's jump to the understanding of how we made this circular loop. We have studied the 4 different circular loops, so we understand quickly that repair, reuse, and refurbish were enabling us anyway to have some kind of remanufacturing or reworking of the sockets, because it has a quality and a safety requirements that are quite tight. So it didn't really make sense for us to go for those first 3 loops, but we went for the 4th loop, which is recycle. The idea was to get the end-of-life socket, build a take-back strategy, get the materials and remanufacture a new socket and see what we can do from it. So this is the loop we have built. The idea is that we would work with demolition companies to get the end-of-life sockets, then shred them, regrind them, get the granulates, then do density sorting for the materials. Thomas will deep dive a little bit more onto that, and then incorporate it in our molding facilities in Denmark to be able to produce the prototypes. So I'll go a little bit through each steps. The first step is the collection of the old sockets. We have looked and analyzed the different materials, what is out there on the market. We track the end-of-life sockets. We worked along with demolition companies to understand what are the behaviors when it comes to end-of-life sockets. And today I can tell you that there is no concrete systematic take-back on the sockets. So today it goes to WEEE, probably landfilled or incinerated. So we have worked quite a lot on understanding the behavior, the consumer behavior, and then the end of life. And we did not actually find a concrete systematic take-back solution to this day. This one of our biggest challenge on the project. So we have started a new project to build this systematic take-back. So we are working with a lot of partners on this one to understand and build our systematic take-back. But for the aim of the project, we find good partnerships, and we managed to collect quite a lot of old sockets. Once this was done, we had to go for the downsizing. So you can see on the picture above, I've circled it in 2 colors. The red one is actually the obsolete material. I mean, you all know that some of the materials today, we cannot reuse them, and it is obsolete materials that are not more commercialized or sold. So we had to do this pre-selection. Today we did it manually because it's a project prototyping, but we are thinking that AI would be more convenient, so we're deep diving into that because it would be way more efficient and we would be more productive on this one. So we removed all of the obsolete material and we kept all the up-to-dates. And from that we made a quick study on what are the materials that are in the socket and what did we get back. from this one, you can see that it's actually a fair split between half of the plastic and half metal. So that was very interesting for Schneider because we have a molding facility in Denmark, so the aim was really to target the plastic. So we targeted the plastic, but still we shred everything, so we're also able to have the metals on one side that we would be selling to someone who would be interested, and us, we keep the plastic for our project. Then when it comes to the plastic, we got the little granulates, and then Trebo came into the game.
Yeah, so at Trebo, we help companies with closed-loop recycling of complex material streams, like the one in this case. So what we do is that the customer ships the waste to our facility in Denmark, also in Copenhagen, where we have a sorting facility. We prepare the waste, which in most cases is removing all of the dust that comes from the grinding process. We size sort the materials. We can also grind at our facilities. And then it's ready for our density sorting, which I'm going to deep dive a little bit into. We sort the desired fractions that the customer wants, and then because we use a wet density sorting process, we need to post-treat it, we need to dry it, for example. We also, if the customer prefers it or desires it, we can also do color sorting. And of course, when we have sorted it and it goes through our quality control, and if it lives up to all of the requirements, for example from Schneider, it's returned and then it's used for new products. Yes. So in this case, as you probably know, there's a lot of metal inside of these sockets. So that was one of the first things we did, was to remove the magnetic materials, but also remove all the dust, and then size sort it. And then you can see, so yeah, we remove the magnetic materials, and then in our sorting process, we also remove the non-ferrous metals. As Alix mentioned, half of the fraction was plastics, yeah. And we focused on PC, PBT, ABS, and PC ABS. And from here, we actually said, okay, let's only focus on one of the plastic types to make sure that we do a good job on that. And the most dominant plastic type in the fraction is PC ABS, and that was why we chose, together with Schneider, we chose to focus on that. So here you see our facility in Denmark, in Copenhagen. We have 3,000 square meters of production, and yeah, we are 25 employees. How our technology works is so it's a technology that we have invented ourselves, and it's a patented technology. How it works is that we have a huge sorting bed. So the diameter of these sorting chambers here, you see here, is 2 meters in diameter, and it works by it's a fluid mechanical sorting process. So you have a sieve in the bottom of the sorting chamber, which can be moved up and down in a certain pattern, a certain movement, and then you do this motion over time with a lot of strokes, and then the materials switch places according to the density of the materials. And I have a small video here showing it. In this case, it's PA6 glass filled 30 with aluminium and brass. It's just for show, and you see not a lot of strokes are necessary to actually to stratify the materials. So you see, you have the brass in the bottom, then you have the aluminium, and then you have the PA6 glass fill. After you see after layering here, you see actually a picture of how it looks with the sockets, where you have the non-ferrous metals in the bottom, and you have PBT, PC, PCABS, and ABS. We focused on PCABS, extracted that. We have a vacuum system, as you can see here with the blue materials down here. Vacuum system that extracts each layer, and we achieve a very, very high purity. Most of the time, it's above 99.5% clean. And that is exactly what we delivered to Schneider Electric, as you see here. A very pure fraction, ready for closed-loop recycling.
Yes, and thanks to this purity of the fraction, then us on our side, we were sure that the PCABS that we were collecting is very pure and it would be working in our manufacturing facility. So that was the next step of our project. The idea was to test it inside our molding machines. So what we have done is that we've taken the recycled PCABS that we got from Trebo that are coming from the end-of-life sockets, and we dried it, and then we mixed it with the raw material. This was a prototyping, you have to keep in mind. So the idea is that we had no clue what would be the results at the end, and we wanted to try it out. So what we have done is that we tested gradually the recycled material. So we added 5% of recycled material coming from the end-of-life sockets, and we added 95% of the raw material, the one that we use today for our sockets that are out there in the market. And we gradually tested, okay, 10% is still working, okay, 20, and then we went up and up and up. And we had quality also engineers together with us at the plant to be able to monitor what does it look like when it comes out of the machines. So we have made the full process, and we ended up having 11 samples. So we went from 5%, then it worked quite well, so we were very optimistic about it. We went up to 100% of recycled material. So of course, as Thomas said, for the aim of this first study, we worked with PCABS. But of course, we're working with the other streams, so PBT, ABS, etc. But I'm just talking about the PCABS, and this is mostly going for the covers of the socket. So I'm deep diving a bit on this one, but of course, we are on the other materials. And the idea is really that, okay, today when you look at it, when the 5% until 30% of recycled content in the socket was actually very positive and very, very encouraging. There were no color differentiation. Glow wire tests were passing. UV aging test is passing as well. So this one were very, very happy and very encouraging. When it goes to the 40% up to the 50%, of course, it looks a little bit sandish. It's a bit, the color difference is not matching exactly, but quality tests are still very encouraging. So we go for up and up. And at 60%, because the color differentiation was so big, we thought, okay, let's try a black socket. So we do not today sell black sockets in the Danish market and on this brand, but we thought, okay, let's see how the black master batch is adhering to the recycled content and how does it work in the molding machine. Very, very surprisingly, I mean, this is amazing. It works really well. No problem on the machines. The adhesion went really well, and everything was very, very good. The quality tests also that has been going afterwards on this black one are also very encouraging. And then we made the 100% socket. I mean, you can see the difference, the color difference. And I also invite you to visit us at the booth M65, where we have all of them presented, if you want to have a look. And the 100% has, of course, later differentiation, so we are making even more quality tests on those to really deep dive on the plastic properties, etc. But all of the quality tests of those were very encouraging. So when we talk about these sockets, then what can we say about sustainability? Today, we have made the test on one polymer, which is PCABS. If we think that we talk about carbon footprint on the PCABS on 2 loops of the socket, meaning one socket produced at our facility with normal raw material, then we take the end-of-life socket and we make another socket, then the loops finishes, then we talk about only 2 loops, then we would be, at the bare minimum, saving 11% of the carbon footprint during manufacturing of these sockets. 11% is only the bare minimum, because we talk about one polymer and 2 loops. But what if we are talking about even more loops? We are talking about even more polymers. This is only the beginning of it. So I'm, of course, being very optimistic on 11% being the bare minimum. And where do we stand today? I mean, that's maybe one of the questions you're wondering. Today we have released the first prototypes, and we have had quite a lot of success on the Danish markets. So I've put a little screenshot about it, but as I mentioned, one of the main challenges that we encountered is the take-back solution. I mean, today the market was not really ready to recycle or to sort out the sockets differently. Today is WEEE. So we are really putting a lot of focus on the take-back solution, working with distributors, demolition companies, consumers, on really making sure that we are saving the sockets at the end and they are not going for incineration or for landfill. So this is our main focus over the next months and maybe year as well. We are also focusing a lot on our partnership. We were very happy to work with Trebo on this one. We have been working with Thomas for 6 years now on smaller projects, and we're happy that we can scale up and that Trebo is following us on this great story. And we are also making sure, I mean, sustainability is very important for us. Also, what do we want to do with our end-of-life projects? What can we do to make sure that we are able to recycle them and that we are able to reuse the plastic? Because solution exists, and it's only the beginning. So today it's a prototype, but we are very much looking forward what's next. So I gave you a little bit of overview on our prototyping of these first sockets. And I guess you know by now that on the app you can plug in your questions, and then we'll be happy to answer with Thomas.
Definitely. For you?
I think it's yours.
It's mine?
I guess.
Should I just press? Or?
So maybe I will take the first question on the quality test. So today we are focusing on the ball pressure test, the glow wire test, as well as the UV aging test, and a couple of others. But those were the 3 first ones that we have concluding that were very encouraging. But we are also going for color measurement test as well as a couple of others. So they are today at the labs going under a way deeper analysis on all of them. So those are the ones I can answer.
Yeah, and from our side, we do density tests. We do FTIR. We have also melting test, MFI, and stuff like that to make sure that it's the right quality.
Yes, I'll take the economical question about the recycled solution. Today, of course, we have made a prototype. So today I can really tell you that today it is not matching the cost of the virgin material, because we had to go through an intensive take-back solution, and then we have to go through a couple of other tests. But today we have worked quite a lot with Thomas from Trebo to understand, to have a full flow, in-house flow. And the bucket that we're missing is actually the take-back. So once we will have this systematic take-back established, we would be able to say that it is more interesting to have the recycled content than the raw material. But today, for the prototyping phase, it is not matching. But with the new flow that are coming up, it will be.
Yeah, and there's a question for me. Do you lose much plastic when extracting? for instance, between layers. If we can go back here, I can show you here. So each layer is extracted here, and then this intermediate layer is extracted by itself in a collection tank, and then it's resorted. So we don't lose any materials in that extraction.
And that also enables a really good purity of the fractions.
There's also a question for me, what liquid is used in the density separation? Only water.
And that's also what's interesting for us on the fraction that we are collecting, the purity that Trebo is able to achieve, as well as the quality of the material, because it is only water. It has a really good composition at the end, which enables us today to be very positive about the quality results. So that's also one important point.
So from our side, regarding the challenges you're facing in the current market situation, so we mostly work with a closed loop with customers. So for us, we're not that hit by how the market is looking at the moment. But we are looking into more open loops where we get like material streams in that are not going directly to the customer again, sorting it and then selling it on the market.
And I can see a question about the sales price of the recycled sockets. What is important is that today our aim was to make a feasibility study on the end-of-life sockets and how can we produce them, how can we remanufacture, and how does it work. So today we are not selling them on the market yet, but of course that's the goal. But the idea was really to study the feasibility, look at what can we do with Trebo, how can we get the socket, how can we get the materials, but also how does it work internally for us for the molding machines. I mean, you know, the behavior of the recycled plastic was not expected. We didn't know what was going to come out of the molding facility. So today we know that it's feasible and we are working on scaling that up. So there's no sales price today.
Question for me, would the sorting technology be suitable for automotive shredder heavy fraction as well? Yes, it would. It would be. I don't know, so I've never tried it, but I think there's of course the value of the materials when you extract them, and what kind of quality we can achieve in that, I don't know, but I would love to try. So if any one of you has the fraction at hand, I would love to try it and see what we can achieve.